Hi there, Mr. Raz here, or Raz here, and today we're going to be doing trigonometry with right-angled triangles. I say that because obviously trigonometry is the broader topic of all triangles. We're going to look at what you've probably heard of as Sohcahtoa today. So firstly, a bit of understanding. We look at these two triangles. We have the pink one and the orange one. We have to ask ourselves, what I want to ask you is, what do they have in common? So hopefully what you've noticed is the one on the right is twice the size of the one on the left. Yes? Now, what's the significance of that? Well, we can say that they are mathematically similar. That means the angles in the orange triangle are exactly the same as the angles in the pink triangle. So we tend to use Greek letters to represent angles. So that means those thetas are the same as the alphas. Yes, so those two angles at the base are the same and the two angles at the top are the same as one another. Why is that significant? Well, it tells us the angles of a right angled triangle are dependent on the ratio of the sides. So what I mean by that is the 3 divided by 4 in the pink triangle is the same as the 6 divided by 8 in the orange one. Yeah, if we take any pair of sides and divide the numbers, we'll get the same answer. So now let's just, before we do any more, we need to label the triangles and discuss the labeling. So here we have the angle theta, and opposite it, we label that side the opposite. The diagonal, which you may know from Pythagoras, is called the hypotenuse. And the side next to the angle is called the adjacent. And adjacent is a fancy word for next to. So that means we always label the triangle with respect to the angle in the question. So here, if I move theta from there to there, this opposite will now become the adjacent, and the adjacent will now be opposite the angle. The diagonal stays the diagonal, so the hypotenuse is still the hypotenuse. So that means we have the following definitions. We have sine theta is the ratio of the opposite to the hypotenuse. Cos theta is the ratio of the adjacent to the hypotenuse, and tan theta is the ratio of the opposite to the adjacent. Yeah, so we need those definitions. I say sine and not sin because it is S-I-N-E. Cos is an abbreviation of the word cosine, and tan is an abbreviation of the word tangent. That brings us to Sohcahtoa. So if you've heard Sohcahtoa before, that simply helps us remember sine, cos, and tan. So if we have the first 3 letters of Sohcahtoa, S-O-H, that helps us remember sine theta is opposite over hypotenuse. Ca helps us remember cos theta is adjacent over hypotenuse. And the toa helps us remember that tan theta is the opposite over the adjacent. It's very important that you spell Sohcahtoa correctly. If you have issues spelling it correctly, then you might try to remember it with this. Some old hag cracked all her teeth on asparagus. That's how I was taught it at school. My teacher, Mr. Alexander, showed me that one. If you notice that the first letter of each word spells out Sohcahtoa. Another one, if you've had a hippie teacher at all, they might tell you that some old hippie came a-hopping through our apartment. Doesn't matter which method you use, you can make up your own one. But they will spell out the word Sohcahtoa. And it's very important that you spell that word correctly. So I'm going to move on now to what I describe as the 3 cases. So if I go back a slide, the 3 cases that will occur will be when we're trying to find the angle, when we're trying to find the top of the fraction, or when we're trying to find the bottom of the fraction. The three cases I'm about to explain are not sine, cos, and tan. That is as simple as pressing a button on your calculator. You can see there's sine, cos, and tan buttons on the calculator. You know, once you decide what to do, pressing that button shouldn't be the most difficult thing. So those are not the cases. The cases are when the angle is unknown and when we have two cases when it's a length that is unknown. The case one is we're going to look at when the top of the fraction is unknown. So if we have this example here, first we need to label the side the opposite. So x is the opposite and the diagonal is 13, is the hypotenuse. For you Sohcahtoa, the opposite and the hypotenuse, which is So. Well, what is So? It's that. So I'll write that down next. Then I fill in what I have. Now what I have is theta is 32, opposite is x, and the hypotenuse is 13. So you can see I've just written it out. Sine 32 equals x over 13. Now those that are strong with algebra will find this next bit easy. You just opposite dividing by 13 is to times. So we end up with x is 13 times sine 32 that we type into the calculator like so. Hopefully you can read that. I'm sorry if you can't. And then we press equals and we get 6.888, which is 6.9 if we round. That's easier said than done. Now, if you're on here because you struggle with maths, you'll struggle with rearranging it. So if that is the case, I suggest you use the formula triangle. You may have seen this in physics or in other sciences. So at the top of the triangle, we'll have the opposite. So that's x. And at the bottom left, we'll have the trig function, which is sine 32. And here we have the hypotenuse, which is 13. So then you know, if you put your thumb over the bit that you need, that is x. Put the thumb on x, that means you need sine 32 times 13. So if you type it that way, it's very important that you close the bracket after the 32. And you will get the same answer. So that's case one. The numerator was unknown. So let's look at case two. The denominator is unknown. So here I have a triangle, my example, and we have to label it. So we have 3.4 is definitely not the opposite. That's the adjacent. X is definitely diagonal, so that is the hypotenuse. So we have A and H. Is it So? No. It must be Ka. What is Ka? Well, cos theta is adjacent over hypotenuse. If we fill in what we have cos 42 is 3.4 over x. So that's what I mean now. The denominator of the fraction is unknown. So you have two steps to rearrange this. First, we times by the x, giving us x cos 42 equals 3.4. And then we have to divide by the cos 42, which gives us this. My advice at this point would be to use the fraction button on your calculator, just located there. And on the top of the fraction, I put 3.4. At the bottom, I put cos 42 and I close the bracket. Now when I press, it tells me 4.57, which is 4.6. Again, if you have problems with your algebra, that's why you're probably on this video, we'll use formula triangle. So this time 3.4 is the adjacent, that's on the top. The trig function's in the bottom left, so cos 42, and x is the unknown. So when we put our thumb over x, we're left with 3.4 over cos 42. We type that in, and we'll get the same answer of 4.6. So that's case two, the denominator was unknown. So it could have been the hypotenuse if we're using sine, the hypotenuse if we're using cos, and it would have been the adjacent if we were using the tan function. Case three, we've had case one and two where we've been trying to find a length. Now case three covers when we have the lengths, but we want to find the angle. So here we have this triangle here, and the opposite is 1.7, the adjacent is 6.8. Right, Sohcahtoa? It is definitely Toa, and Toa is tan is opposite over adjacent. The next step is simple, so we write it in, and that's what we have. Now, to tell the calculator that we're trying to find an angle, you must press shift on the calculator. So the shift button's in the top left-hand corner. So I'm going to press shift and then tan, and now type in 1.7 over 6.8, and I must close the bracket. So that's what I'm typing into the calculator. I hope you can see that. And I press equals, that gives me 14 degrees. So case 3, as I describe it, is when we have a missing angle. When we have a missing angle, you press tan inverse, cos inverse, sine inverse, which can be accessed on your calculator by pressing the shift button before tan, cos or sine. So again, let me reiterate. I've not classed the 3 cases as sine, cos and tan. I've classed them as case 1, when the length is the numerator and that is unknown. So that will be the opposite for sine, adjacent for cos, or opposite for tan. Case 2 was when the denominator is unknown and that is a length. That will be the hypotenuse for sine, hypotenuse for cos, or the adjacent for tan. And case 3 is when the angle is unknown. So having filled in which lengths you have, you need to press one of shift tan, shift cos, or shift sine on your calculator to find the angle. So before doing the next video, before viewing the next video, answer these 9 questions, and I'll look forward to seeing you soon. I hope that was helpful.